Hello and welcome to this session, guys. In last session on Amazon VPC, we have talked about Amazon VPC basics and main components of VPC service. In this session, we are going to talk about basics of VPC creation. So in this session, we are going to have a lab where we will talk about what steps need to be followed to create a VPC, subnet, and how you can attach subnet to internet gateway, how you can create custom routing table, and how you can attach a subnet with a routing table. So let's begin. I believe you have already watched the last video, but again I want to cover the basics. Amazon VPC. VPC stands for Virtual Private Cloud. VPC is one of the fundamental and widely used AWS service which provides a virtual network dedicated for your AWS environment. VPC is logically isolated from other virtual networks in the cloud and exists within a single region. Benefits of using VPC: you can define your custom network. You can assign static IPv4 addresses to the instances. You can define network interfaces and attach one or more network interfaces to the instances. You can define routing between different subnets. You can define the internet access for the subnets. Also, you can define network security by allowing or denying the traffic. So what we are going to cover in the lab today. In this lab, we are going to create a new VPC. The VPC will be having two subnets. One subnet will be having internet connectivity, or you can say public access or public network basically. And the second VPC will be without internet connectivity. Both subnets can talk with each other through the default routing table. But we will allow only specific port using security groups. So guys, what's the logic of picking two security groups, one with internet connectivity and second without internet connectivity? So let's assume a scenario. You got database servers and you got application servers, or you got web servers. So your web servers are internet facing or public facing, where anyone can connect from internet. No one need to connect to your database servers because your application or web servers will be talking to your database servers. So what we are going to do, we are going to keep our database servers in subnet which will be not having internet connectivity, and we will put our application server in the subnet, in the internet facing subnet. So you can use term application server or web server because this is only demo. So I'm not making it more complicated, because you can add multiple layers. You can have your application servers, you can have your web servers, then you can have your database servers. Based on your application or your environment requirement, you can create multiple VPC and multiple subnets. But I just want to keep this session with basics, so I'm just creating two subnets. I'm repeating again, one will be having internet connectivity, one will be without internet connectivity. You can see on my screen the VPC which I'm going to create. I'm going to name it as AWS lab-VPC, and the CIDR blocks would be 172.16.0.0/16. Why I'm picking 16? Because we can have many IP addresses in this particular CIDR block. The first subnet which we are going to create, that would be named AWS lab-subnet-public. Basically, this will be having internet connectivity. The CIDR would be 172.16.1.0. You can see here the third octet is 1. This particular subnet would be having internet connectivity. Basically, internet gateway will be connected to this particular subnet. Routing table will be named as AWS lab-rt-internet. The second subnet will be named AWS lab-subnet-private. CIDR block would be 172.16.2.0/24. See, I have only rotated third octave. So if you want to create your third subnet, you can again rotate the third octet. You can pick 172.16.3.0.4.0. In that way, you can have multiple subnets. So this subnet, the private subnet, will be not having internet gateway connectivity. And by default, these both subnets can talk with each other using the default routing table. So I'm only going to create one routing table with internet connectivity rules. So let's begin. So guys, you can see on my screen, I'm already logged on to my AWS console. So here, first thing we have to do, we have to select VPC service, and VPC is here. I'm just clicking here. And you will notice by default there is no VPC, but I mentioned by default there would be one VPC. That's something I mentioned in last session. Why we are not having any VPC? Because I have deleted the default VPC. I don't want to get confused with old VPC or original VPC and my custom VPC, so I have deleted the old VPC. So everything we can do from scratch. If you want a VPC with the single subnet only with the public connectivity, you can use Start VPC Wizard. With that one, once you click that, in 2 clicks you will get one VPC with the single public subnet. That's something which I mentioned I don't want, so I'm just canceling it. We will create our VPC from scratch. But if you follow that way, in that way, no need to create routing table, no need to define networks, because everything would be created with a couple of clicks. But in this lab, we are going to create our custom VPC. So first thing we have to do, we have to go to VPC here. Right now there is no VPC, so let's create our first VPC quickly. So I'm clicking here, create VPC. So name tag would be our VPC name. We will name it AWS Lab VPC here. Okay, so this is done. And IP v4 CIDR block. As I mentioned, we are going to use 172.16.0.0/16, and we are not choosing IPv6 here. I'm clicking yes, great. So it will create a VPC. It may take a couple of seconds. Okay, that's done. You can see name, and this is the VPC ID, which would be unique for every VPC, and state is available. This is the CIDR. This is the DHC option set. By default, DHC options would be set. Basically, any instance which is using this VPC, that would be having automatically allocated address using DHCP. Routing table, you can see we haven't created any routing table, but by default a routing table would be created when you create a VPC. So this is a default routing table. This is the default DHCP option. This is the network ACL, which is also created by default. And here you can see this is not default VPC, but you can change it. You can change the things in action. You can, if you want to edit the CIDRs, you can add it. If you want to add DHCP options, because right now these are the DHCP options. If you don't want to use DHCP, you can say no DHCP. I'm canceling it. I want to go with default option here. And in case you want to add deny the DNS resolution, because by default it's yes, you can say no, then your DNS resolution will not work for that particular VPC. But I'm sticking with yes. When it is needed, when you are using, let's say, direct connect, you are using your own DNS server instead of Amazon's, in that case you can say no here. But I don't have direct connect, I'm using basic Amazon thing, so I will not change it. Okay, so next thing, we got our VPC created, guys. As I mentioned, now we are going to create 2 subnets, one with name public, one with name private. So let's create that. Always use the prefix, because this is the prefix in my case, AWS Lab. So all the components which I'm going to create, I'm going to use name or prefix AWS Lab. So I'm clicking on subnets now. Right now there is no subnet, because by default subnets are not created when you create your new VPC. With default VPC, you will see subnets, but with your custom VPC, you will not see any subnet by default. So we have to create our subnet as per our requirement. Okay, so let's create our first subnet, which would be named as AWS Lab-subnet-public. So clicking here, create subnet, name tag. This is the name, AWS Lab-subnet-public. If you see by default, we only got one VPC, so it picked the VPC. In case you got multiple VPC, so you have to select appropriate VPC ID. And this is the VPC CIDR. Availability zone, no preference by default. There are 3 availability zones in Southeast, 2, Basically I'm at Australia. So 2A, 2B, 2C. So in this case, I'm going to put everything in availability zone 2A. Okay. Now IPv4C idea block. So this particular block is for this particular subnet. So IP addresses would be allocated from this particular block. So I'm choosing 1.0 as I mentioned in theory session. Clicking on yes here. So it will create a subnet. Okay, so let's quickly create second subnet also. Then we will do the next things. Here I'm naming it dash private at the end. Again putting it to A, and here CIDR block I'm picking 2.0. I'm just rotating the third octet /24. Yes, create. So it will create a new subnet. Okay, we got two subnets and you can see both are in 2A, and by default they are attached to the default routing table. That's a reason subnets can speak with each other, because by default they will get the default routing table. And these are not default subnets. Auto assign public IP set to no. Basically what it means, public IP basically when you want to access your EC2 instance using its public IP. So by default it is set to no. So you would be not able to assign. For first subnet, which is our public subnet, which we are going to configure as internet facing, so we can change the properties. We can click here modify auto assign IP address, because for this one I will prefer it automatically selects that option that public IP address would be assigned. I'm only setting it for my public subnet, not for private one. Now you can see here it's set to yes, assign public IP yes. So it means public IP address would be allocated whenever we create a EC2 instance using this subnet. So that's something good. Okay, now let's go to a routing table, which is a third thing. Well, before going to routing table, I would prefer to go to internet gateway, because we want internet connectivity for our public subnet. For that you can simply click create internet table and you can name a tag. So we can call it AWS lab dash internet gateway IT, or you can say internet IGW something dash public, or whatever name you prefer, and click on create. So this particular internet gateway is created. But so first thing we have to do, we have to attach this to a VPC. So I'm clicking here attach to VPC, so it will attach. It is asking which VPC. Right now we only got one VPC, so I'm selecting yes. In case you got multiple VPCs, make sure you're selecting appropriate VPC. So if you see here now, internet gateway is attached to this particular VPC. That's good. So next thing, we will add a custom routing table with internet connectivity. This is the default. As I mentioned, whenever you create a VPC, by default a routing table would be created. So I'm just naming it default, so I will not get confused or make some unnecessary configuration. So this is the default one. I have just added name default. So let's create a new routing table, and we will name it AWS lab -RT internet. So we will remember that's for internet connectivity. Clicking yes, create. Okay, new routing table created and it is selected, but it is not associated with any subnet. So first thing we have to do, we have to add a route so anyone can access this particular routing table. In routes, we are going to add a new route, add another route. I'm saying from anywhere /0, and here I'm selecting internet gateway, anyone can access, and clicking on save here. So you can see a new route is created, like from anywhere this particular gateway can be accessed. This is a route, basically from anywhere route the traffic to this particular. State is active. Now we have only created a gateway and created a route, but we have not associated this particular route or the new route with any subnet. So that's not useful, or basically you can say it's useless until or unless you associate it with a subnet. So I'm clicking on subnet association. By default we got two subnets. So now to which particular subnet we want to attach. So first thing, you have to click on edit. You can select to which particular subnet you want to associate. As I mentioned, we want to associate only with public. So I'm selecting public and clicking clicking save. Okay, you can see this particular route table is associated with public subnet, not with private. That's good. So guys, what we have done till now, we created VPC, then we created two subnets. Third thing, we created internet gateway and attached it to VPC. Then we have created a custom route and attached that particular route with our public subnet, and we have added a route 0.0.0.0/0 and attached it to internet gateway. So these are the things done till now. It means our network is ready. To now we have to secure our systems. For that we have to add security groups. For that we will be configuring two security groups. One security group we will configure for our, let's assume, for database servers. One security group for internet facing web servers like port 80 you can say, or port 443. And on the private subnet, basically, which is for our database servers, which we are assuming, we will allow only custom ports. We will allow port 22, port 3110. Let's say this is custom port which we want to allow. So let's do that quickly. To create a security group, basically you have to go to your EC2 service, click on services, then go to EC2, then click on security groups. Here you can see there is one default security group which is automatically created when we created VPC, but we want to create our custom security group. So click on create security group. Let's name it AWS Lab SG for security group. Let's call it database servers or database. Description for, like, I'm just mentioning some dummy thing, database something, databases, and this is the VPC. Here let's add rules. So I am allowing SSH connection from, I'm not allowing from anywhere. Basically this is not associated with the internet gateway, so there is no risk, but still I want to restrict it even in my custom network. I'm saying custom. Here in CIDR I'm saying allow only from 172.16 dot our public machines. Public subnet was 1.0/24. Only allow SSH from these particular servers. Then I'm adding another rule where I'm saying allow custom connectivity. I'm saying custom TCP over port 3110 from, again I'm choosing custom, this particular machine. I'm adding third rule. I'm saying allow ICMP again from this particular subnet. So connectivity to this particular, if someone use this particular security group, will be only allowed from this particular subnet. So that's where we are secured. So we have configured our firewall, and let's name it. We will name it AWS Lab -SG/database. Clicking tick, and let's quickly add a second security group for our app connectivity. I'm naming it AWS Lab SG/public. So here I'm saying this is internet app server something, and here I'm adding rule. I'm allowing let's say connectivity on HTTP from anywhere. Adding another rule here, I'm allowing connect all the ping request from anywhere. Okay, and I'm allowing SSH because I have to SSH to this machine from, or I can say from my IP. This is my IP, my machine IP. Otherwise you can choose a subnet, or you can allow from anywhere, but I don't prefer anywhere. I'm only allowing from my IP address. Clicking create here. So this is a group got created. Sorry, I did mistake. Earlier I added name here, so I'm just taking this name out. This name is for our database security group, and for our public group I'm naming it public here. So guys, we got two security groups created to handle inbound traffic. So that's done. Now our VPC is created, and subnets created, routing done, internet gateway connectivity done, and we have created security group. So everything is done, guys. So that's the way you can do the things. But now next thing we want to do, we want to test our configuration. So how we can test whether this configuration is working or not, and whatever the rules or configuration we define, that's active or not. So we are going to create two servers quickly, and let me do that, where we will use these subnets and VPC launch instances. I'm picking Red Hat AMI. Okay, configure instance detail. You can see our default VPC, and first server I'm going to create in public. This is going to be our application server, which would be having internet connectivity. So clicking add storage, 10 GB is fine, add tags is fine, and let me add a name tag. I will name is name app server something. Okay, so clicking configure security group. In security group I have to pay attention here. I'm selecting existing security group with public connectivity. So I'm not picking default. With default you will get connectivity for most of the things. Click review and launch, and click launch here. I acknowledge. I will pick this keep here because I got access to this keep here. So this is our first server which is getting built, and let me quickly create a new server with the name database, and we will put it in the subnet which will not have internet connectivity. So again, launch instance, same AMI, same instance type is fine, but here I'm choosing private, which is by default selected. Clicking add storage, 10 GB is fine again, and I'm tagging it. I'm calling it database, so I will be aware. Configure security group. In security group I'm select an existing security group. I'm going with database, review and launch. Here when I click launch, I will select my key. Okay, it is getting built now. Let me go to main instance page. So both instances are getting built, app server and the database server. So guys, app server we can connect from anywhere, database server we can't, and database server would be not having internet connectivity. Basically it can't be connected from outside. So I can show you this thing quickly. Let's both servers get built. You guys can see on my screen both servers are in running state. The server app server got public IP because for that particular subnet we have allowed public IP auto assignment, but for database server it not have any public IP because we don't want to give access to this server from outside, means from internet, and we have not selected assign public IP option. So you can see that's a difference. First thing works good. So let's connect to our, because no one can connect to database server from outside because it is not having public IP, right? So let's quickly grab this IP, which is our app server IP file, but let me first try to ping this IP quickly. So this IP is pinging, that's good. So let's try to SSH this IP using PEM file, and we have to connect with EC2-user because that is default one. And here at the end I'm specifying my PEM file. Basically you can say identity file. You can see we are on our instance, so that's good. Our internet connectivity work. Let me elevate my privileges. Okay, now you can see we are on a machine with public access. So let's try to ping Google quickly. We are able to ping. It means internet connectivity is working fine for this particular machine. So now let's test our second thing. Let's quickly grab the IP address of database server, because we have allowed the subnet to connect from subnet 1, which was public subnet, and this is the IP address of database server, which got 172.16.2. Just pay attention on third octet, it's 2. For the first one, let me show you quickly. It would be having 1 dot something. You can see 172.16.1.33 because it's getting picked by DHCP. You can see if I do SSH locally, it is working. I'm just saying no, I don't want to go into that one. So you can see connectivity is working, but we can't connect this IP from outside because that's a private IP. This particular database server is not having public IP. So that's the way, guys, it is working. So let me quickly show you. Telnet is not by default available. Let me see if nmap is there. Nmap is not there. NC is also not there. So I can quickly install telnet. So I can show you guys that port 3310 or 3110, which we selected in subnet, that's open. That's only to give you quick demo. So guys, you can see I tried to telnet to database server IP over port 3110. We got immediately connection refused. It means port is open, but service is not listening on this port. So that's good because we haven't installed any service or executed or started any service on this port. So that's good. In this way, guys, things works, and you can create multiple subnets based on your requirement. Based on your requirements, you can configure multiple security groups. You can also create configure access control list. So thank you guys for watching this video. If you have any query, any suggestion, just leave a comment on my YouTube channel. Thank you guys. Bye.